All right, now we continue on our base correlated equilibrium, and the here we'll verify our example and show the actually our outcome is BCE. Okay, by showing the verifying the consistency and the obedience. Okay, so this is just a continuation of the last video. Okay, so remember that. Okay, we call that our example, and between the further information design between the designer, the prosecutor, and the decision maker of the judge, right? And we can find all those numbers in the previous episode. Okay, all right. Here we concentrate on our outcomes. Okay, rather than the being, rather than the previous Bayesian Nash. Here we use the BCE. Okay, so all right, our V is just the joint distribution over the state and action, right? Such that so the V of convict is action, okay, and the state is G, okay. Perhaps I should write A times omega. Now this is this had the same order as our examples here. Okay, then this is just 0.3. Okay, and we can find this in the earlier videos. And acquit given I is 0.4, and V of convict I is 0.3, and V of acquit given G is 0. Okay, and this is partially implementable. Okay, and we show that this V is BCE. Okay, so the first thing to check is the consistency. So the consistent means that the marginal distribution equals to prior, right? So the V of convict given G plus V of acquit given G for the G's. So this is just 0.3, right? And of course, recall that our prior of big G is 0.3. So it's correct. And V of convict given I plus V of acquit given I is nothing but 0.4 plus 0.3 is 0.7, and of course it's mu naught I. Okay, so it's also correct. And the next thing to check is obedience. So for the first, okay, you just write for the convict, okay, first. So V of convict, big G, U convict G. So the first is no deviation, okay, so the obedience here, plus V of convict I, U convict I, okay. So in those two cases, then how about the expectability induced from convict? This is 0.3 times 1 plus 0.3 times 0 is 0.3, okay. But if deviation, then it becomes, so the V's are the same. Remember, with deviation, outcomes are the same, but the utilities are different because of the deviation. And this is just acquit and G plus V convict I, U acquit I. So this is 0.3 times So 0 plus 0.3 times 1, and it's 0.3. Okay. And again, 0.3 is greater than or equal to 0.3, so it's okay. So for the convict, it satisfies the obedience, no problem. Okay, then the next to check is for the acquit. Okay, so similarly, we acquit I, you acquit I. So this is I, and how about G? We acquit G, you acquit G. So this is 0.4 times 1 plus this is 0 times 0, and this is just equal, and this is 0.4. Okay, but what if deviation? Okay, so the V's are the same, acquit I, acquit G, but inside of U's, so this becomes convict I and convict G. Okay, so this is 0.4 times 0 plus 0 times 1, and it's 0. So 0.4 is greater than 0, of course. Okay, so we have already checked all the actions. So the expect utilities for the obedience, for listening to the action recommendation, it yields a higher or the same expect utility of deviating. Okay. So the obedience is verified, it is satisfied for the requirement. So this V is a BCE. Okay. All right. So now this is the whole process of verifying our example in terms of this our outcome V is a BCE. Okay, so the reason that we are using the BCE is actually it really helps us to perhaps simplify the information design problem, and later in the future episodes we will show that we're going to reformulate the information design problem or the business persuasion problem, especially with multiple receivers. So it's pretty easy for us to use this incomplete information game structure to actually convert that problem into a linear programming problem, which is more technical and is easier to solve. Okay. All right, that's it.